All right, hello. Today we're going to be talking about 7.5, which is going to be going back to factoring polynomials and solving polynomials using some of our factoring strategies. A couple of quick definitions. The degree of a polynomial is just the highest exponent. It says the highest degree, but it's the highest exponent of a polynomial. It's like if you had x to the power of 5 plus maybe x squared plus 1. Whatever your biggest exponent here, that's a 5, is your degree. So this would be degree 5. It's kind of important to know that because we have something called the fundamental theorem of algebra, kind of a crazy sounding name, very important sounding. And you've used this for as long as you've ever learned algebra. We just don't always really put a name on it. And that is that any polynomial n will have exactly n roots. And we also say solutions or zeros. So like if you have, let's see here, a polynomial with degree 2, let's say x squared minus 4, that means you have 2 solutions. If you have x to the power of 3, you have 3, x to the power of 1, you have 1. This comes up all the time in algebra without even really knowing it. And we'll kind of use that to double check our work as we go along here. When we are solving by factoring, we're going to do some similar stuff and just adding a couple steps. So we want to set our whole equation equal to 0, just like we did with solving by factoring with quadratics. We want to factor completely using our strategies from the previous lesson, and then set all of our factors equal to 0. So sometimes we'll have 1, 2, 3, or 4 things to set equal to 0. Every now and again, we're going to have to solve using square roots, the quadratic formula, or using that kind of reliable X diagram that we've used a few times so far this year. So starting off, it says solve the following by factoring completely and then using the zero product property. Our first step with factoring is always, always, always finding a greatest common factor. Here we only have 2 terms, so that only kind of leaves us a few options. But I see really quickly that we do have a greatest common factor, x to the power of 3 plus x equals 0. We can factor out an x here. And when we factor out that x, when we divide that out, we're left with x times x squared plus 1 equals 0. This doesn't look like we factored it all the way. We really didn't do much, just this greatest common factor. But that's actually all we can do. Now we can go ahead and take our 2 factors here and set them equal to 0. Our first one is just x equals 0. Nothing to really solve for there, that's fine. Our second one will be x squared plus 1 equals 0, meaning that we have to solve using square roots. I'll start off by subtracting 1 on both sides to give me x squared equals negative 1, and then take the square root of both sides. Remember, the square root of a negative number, we're going to have a plus minus, and we're going to have an I. So our final answer here is x equals positive negative I and 0. I want to really quick bounce back to our fundamental theorem really quick. So this is saying that we have polynomial of n degree, we're going to have n solutions. Here I've got a degree of 3, and I have 3 solutions, positive I, negative I, and 0. So it's always good to double check, make sure that you've got the amount of solutions that you need. Moving on to number 2 here, we have a very similar question, but our equation is not set equal to 0. We can fix that really quick though. I'm just going to subtract negative 3x squared on both sides. That'll cancel it out on the right, setting our equation equal to 0, and give us 4x cubed negative 10x squared equals 0. Now we want to go ahead and factor. Again, we have 2 terms here. I always want to look for a greatest common factor first. Here I can factor out a 2x squared. And when I divide out that 2x squared, I'm left with 2x squared times, let's see here, 2x, and then minus 5. Still equals 0. Now we can go ahead, this is as factored as we are going to get it, so we can go ahead and set both these equal to 0. So first one, I'll set 2x squared equal to 0. And with this one, everything kind of cancels out. If you divide both sides by 2, you're left with x squared equals 0. And when you take the square root of both sides, you get x equals 0. On the right, 2x minus 5. We just need to kind of solve this one down using our algebra strategies. So adding 5 to both sides to get 2x equals 5, and dividing both sides by 2 to get x equals 5 over 2. We do kind of run into something weird though, because let's think back to our fundamental theorem. We have one solution and two solutions, but our fundamental theorem is saying we're supposed to have three solutions because we have a degree of 3. And here's what happened. Whenever you take the square root, even though this is still a 0, we could say positive negative 0, but that doesn't really make sense because positive 0 and negative 0 are the same thing. So we would say we have the answer 0 and 0. This comes up a lot. Whenever you get the same number as a solution twice, instead of writing it out twice like that, in our final answer we'll say x equals 5 over 2, and we'll say x equals 0 with a multiplicity of 2. That's saying we have the answer 0 twice, and that's where our third answer comes from. You'll see that a ton more. Don't really worry about it yet because we're going to see it a lot more, and we're going to see a kind of a more visual representation as the unit goes on. Just know if you get the same answer twice in the same problem, it means it has a multiplicity of 2. Moving down to number 3, this is kind of an interesting one because we have x to the power of 4 plus x squared minus 42. But remember, whenever you're in this kind of unique form where you have x to the power of 4 and an x squared, you can treat this as a normal trinomial, meaning that we can use our x diagram that has been so handy to us so far. My a times c will be negative 42, so that's going up top. And my b is just a 1, so I'm looking for two numbers that multiply to give me negative 42 and add to give me 1, which gives me a 7 and a negative 6. Now I can simplify this in factored form by writing it out as x squared plus 7 and x squared minus 6. Because our a value is 1 here, we can kind of just take this shortcut. Now let's set both of these terms equal to 0. So x squared plus 7 equals 0. I'm going to subtract 7 on both sides, get x squared equals negative 7. And then I'll take the square root of both of those to get x equals positive negative I root 7. Remember that I comes from taking the square root of a negative number. On the right side here, I will set this equal to 0, x squared minus 6 equal to 0. When I add 6 to both sides, I have x squared equals 6. And taking the square root gives me x equals positive negative root 6. Let's kind of put our answers together here so it's a little bit neater. My 4 solutions are x equals positive I root 7, x equals negative I root 7, x equals positive root 6, and x equals negative square root 6. Looking to number 4, here we again have this issue where we have some values on the right side and the left side. We want to get rid of those. I'm going to add my 9x to the power of 4 to both sides. And I'm going to subtract my 13 on both sides just to kind of get everything away from this right side. This leaves me with 10x to the power of 4 minus 10 equal to 0. And here we got a little bit of work to do because the first thing I see right off the bat is we have a greatest common factor. Anytime we see that, I want to get rid of it. So I want to factor out that GCF to give me 10 times x to the power of 4 minus 1 equals 0. We don't really have too much more it looks like we can do, but we do have this x to the power of 4 that we don't really want to deal with. If we go way back, we can remember our difference of squares, where we actually have a perfect square for our a and our b here, and we're subtracting, meaning we can factor this out using our square roots method, difference of squares. This gives us 10 times x squared plus 1 and 10 times x squared minus 1 equal to 0. Now we can go ahead and set our x terms equal to 0. Remember, we don't need to set this 10 equal to 0 because 10 is not equal to 0. So don't say that one of your solutions is 10. We can't solve that, so that kind of gets canceled out. For our next two, though, I'll set my x squared plus 1 equal to 0. When I subtract 1 on both sides, that gives me x squared equals negative 1. And my square roots leave me with x equals positive and negative I. Square root of negative 1 is I. Then on the right side here, x squared minus 1, I'll set that equal to 0. So that'll give me x squared equals 1 when I add 1 to both sides. And the square root of both sides gives me x equals positive and negative 1. So our four solutions here are x equals positive negative I and positive negative 1. Sometimes you might see people write this as negative I, negative 1, and positive 1. That's okay too. Both are technically correct. Some people just have different ways they want it to be written. Moving on down here, number 5 gives us x to the power of 3 minus 8x squared plus 16x equals 0. Always checking for a greatest common factor first, and that helps us out a ton here because all of these can be divided by an x. The reason that helps us out so much is once we divide an x through to all of these, it leaves us with this really nice x squared minus 8x plus 16 equals 0. And the reason I love that so much is because our term in parentheses there is just a normal trinomial. We can factor this just like we're used to. So we're saying we're looking for two numbers that multiply to give us 16 and add to give us negative 8. And those two numbers are negative 4 and negative 4. In factored form, we're looking at x times x minus 4 times x minus 4 equals 0. And now let's set all three of these equal to 0. First, we'll set our x equal to 0, giving us just x equals 0. And for both of these, x minus 4 equals 0. We'll just add 4 to both sides, get x equals 4. Remember, we have a degree of 3, so we need our 3 solutions. And that third solution is going to come from that multiplicity. So for my final answer, I'll write that x equals 0 and that x equals 4 with a multiplicity of 2. Last one on this page, we have number 6, 2x to the power of 6 minus 10x to the power of 4 minus 48x squared equals 0. Just like with a lot of these problems, we do have a GCF that we can factor out that's going to make this problem a whole lot easier. We can factor out a 2x squared. When we get that divided out, we are left with x to the power of 4 and then minus 5x squared minus 24. And this is one of those kind of special cases where even though we have an x to the power of 4, we can still use our x diagram. So two numbers that multiply to give us negative 24 and add to give us negative 5. That's going to be negative 8 and positive 3. So our factored form of this equation will be 2x squared, and then in parentheses, x squared minus 8, and then x squared plus 3. All equal to 0. All right, now let's set all three of these equal to 0 to get our final solutions for x. This first one, if we have 2x squared equals 0, we'll divide both sides by 2, take the square root to get x equals 0 again. For this next one, I'm actually going to write really quick so I don't forget here. We are taking the square root. So that is going to give us a 0 with a multiplicity 2. I'm going to make a note of that so I don't forget to write it down in my final answer. And then we'll move over to this x squared minus 8 equals 0. If I add 8 on both sides, I get x squared equals 8. Take the square root of both sides to get x equals the square root of 8. Ooh, x equals positive negative square root of 8. And then lastly, we have x squared plus 3 equals 0. Subtract my 3 on both sides, get x squared equals negative 3. And then take the square root of both sides, get x equals positive negative I root 3. So we kind of have a lot of different things going on in our final answer here. So let's get it all written down really nicely. So the first thing that we have, I'm going to kind of try to write these in an order that makes a little bit of sense to me, is this square root of 8. Square root of 8 can be simplified a little bit, so let's go ahead and do that. We could say, split this up into the square root of 4 times the square root of 2, meaning we have x equals positive negative 2 root 2. We have this positive negative I root 3 here. And then we have our 0 multiplicity 2. So a lot of different things going on in our final answer here. And then we can double check. We have a degree of 6. So we know we need to have 6 answers. And here we have 1, 2, 3, 4, 5, 6. So we're good to go there. Moving down to our next page here. A lot of going to be kind of similar strategies, but just looking at a couple different ways. So first one we have here, number 7, 3x to the power of 4 minus 2x squared equals 16. We know that this needs to be equal to 0, so let's subtract 16 on both sides. That'll give us 3x to the power of 4 minus 2x squared minus 16 equals 0. This is one of our trinomials that we can solve using our x diagram, and this is kind of a nice one because it shows us a little bit of why this method even works in the first place. My a value is 3, my c value is negative 16 here. I don't have a greatest common factor, even though it looks like I should. But when I take 3 times negative 16, that gives me negative 48. My b value here is negative 2. So I'm looking for two numbers that multiply to give me negative 48, add to give me negative 2, and that'll be negative 8 and positive 6. Because our a value isn't 1 here, we actually have a number in front of that first term. We can't just kind of skip all those steps. We have to write this one out in factored form and do it manually. What I mean by that is we'll have 3x to the power of 4, and then negative 8x squared, positive 6x squared, and then still minus 16 tacked on at the end here. Just replacing that negative 2 with these two factors here. Now that we have 4 terms, we can factor this out by grouping. So looking for 2 greatest common factors. For this first group, all I can factor out is an x squared, which would give me an x squared on the outside, and a 3x squared minus 8 on the inside. And in my second group here, I can factor out a 6. No, not a 6. Let's see here. I can just factor out a 2. So that would give me, again, 3x squared minus 8. Our parentheses match up here, which is exactly what we're looking for, meaning that we're good to write this in factored form of x squared plus 2 and 3x squared minus 8. Now let's go ahead and set both these equal to 0 to get our final answers. So x squared plus 2 equals 0. We'll subtract 2 on both sides, get x squared equals negative 2. We'll take the square root of both of these to get x equals positive negative I root 2. On the right here, when I take my 3x squared minus 8, again, I want to separate this. and set it equal to 0. And I'll do that by adding 8 to both sides. 3x squared equals 8. Dividing both sides by 3 to get x squared equals 8 over 3. And then taking the square root of both sides to get x equals the square root of 8 over 3. In the future, you're going to want to have to do, when we move on to graphing, a couple of different things to this answer. Ooh, forgot my positive, negative, positive, negative. To clean it up a little bit, change it into a decimal would be fantastic, but for now, let's just leave it as the square root of 8 over 3. It's not perfect, but for now, it'll be just fine. So plus or minus I root 2 plus or minus the square root of 8 over 3. Moving down to number 9 here, the last kind of form of questions that we have here, and this is when you have 4 terms to deal with. 4 terms all on the same side of the equal sign. This is all equal to 0. That's good to see. We don't have to move anything over. When I go ahead and do these two groupings, the first one I get here, x cubed plus 2x squared, my greatest common factor is x to the power of 2. So x squared times x plus 2. My second group here, 5x plus 10, my greatest common factor is going to be a 5. And then again, I've got this x plus 2. Our parentheses match up, so we are good to write this out in factored form. X squared plus 5 times x plus 2 equals 0. And let's go ahead and solve for x on both of these. So first, the 5x squared plus 5 equals 0. I'll subtract 5 on both sides, get x squared equals negative 5. Square root of both sides, get x equals positive negative I root 5. And on the right side, this one isn't too bad at all. X plus 2 equals 0. Just subtract 2 on both sides to get x equals negative 2. So our final answer, positive negative I root 5 and negative 2. And that is all for our notes today. We're going to keep practicing these skills as we go along, and we'll see a lot of these things and a lot of these vocab words more as the unit goes on. Have a great day.